Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start today's webinar by thanking Memfault for sponsoring the event. Memfault is a leading supporter of the IoT Central community, and we're grateful to have them as sponsors. Today's webinar is entitled How to De-risk IoT Product Launches with Device Reliability Engineering. Before we begin, I'd like to briefly review the format of today's proceedings. This event is going to be 1 hour long. We're going to have one presenter who I'll introduce in just a moment, and there'll be a Q&A session after the presentation. So now I'm very pleased to introduce today's speaker, François Baldassari, who is the CEO of Memfault. Whenever you're ready, François, take it away.
Thank you, Max, and thank you to the IoT Central community for having me today. So today I'm going to be talking about only two things, but as it turns out, they're big things. So we'll have a lot of content to go through. Number one, I want to talk about shipping on time. I'm sure everybody here who has worked on a hardware device or an IoT device thinks about this a lot. It's a general concern. I think every program I've worked on gets terribly close to not shipping on time, and yet somehow, most of the time we make it. The second thing that I'll talk about is how do we de-risk the launch? Because as we know, shipping is not the end of the work. Oftentimes, it is also the beginning of a new kind of work. But first, I'd like to let you know a little bit about who I am and why I am passionate about this topic. So as Max said, my name is François Baldassari, and I'm the founder and CEO of Memfault. Memfault is a company where we help hardware businesses ship their products and make sure that those launches are successful. I'm very passionate about tooling and automation in software engineering. I'm always the engineer who builds tools for his colleagues and is constantly trying to improve systems and processes. It's just how I've always liked to work. So I've had the pleasure of working on devices like the Pebble watch, the Oculus virtual reality headsets, the Oculus Quest, and earlier on in my career, big servers at Sun Microsystems. That was almost a whole other job, working on Spark CPUs and really large systems that did, that had serious amounts, like terabytes of RAM in some cases. You can learn more, or you can read about my journey and my experience as a firmware engineer on Memfault's Interrupt blog, which you can find at interrupt.memfault.com. All right, so let's talk about shipping on time. First, what does it take to actually ship a product? Let's agree on a few terms so that we can make sure we talk about the same thing. I'm going to walk you through a typical NPI timeline, where NPI stands for New Product Introduction. The terms that I use, EVT, DVT, PVT, are major milestones in most programs, but they may not be familiar to all of you. So I will walk you through what each of them is. These terms are, I think, inspired by Apple, which has used them internally for a very long time. And because Apple folks, tend to populate other hardware companies over time, those terms have proliferated through the industry. So at the beginning of a program, let's say that we are shipping a consumer electronics device. So we're on a 1-year timeline. We've got to get the product out the door around September so that it can be on shelves at Best Buy and be in the hands of people for Christmas, right? That program will start with a prototype phase. The prototype phase is the longest of all the phases. It's when we figure out what we want to build. 12 weeks seems like a lot of time at the beginning, but it turns out that 12 weeks goes really fast when you're prototyping and iterating, because you have two things happening in parallel. On the one hand, your industrial designers are trying to figure out, what's a raw form factor for this device they make, looks like prototypes, which may not do anything, but show what the device might look like. and your electrical, mechanical, and firmware teams are building works-like prototypes that may be duct taped together and quite ugly, but give an idea of the functionality of the device. And during that time, we really have to explore the space of possibility for the device, because once we get into the engineering milestones, it becomes much more about implementation rather than exploration. So after 12 weeks, hopefully, we have a rough idea of what we want to build and how we're going to build it. We've experimented with some sensor systems, we've experimented with different actuators, and we have a plan. We then move to the validation tests milestones. We start with EVT, engineering validation tests, where we have basically 6 to 8 weeks to go from our latest prototype to a handful of different configuration of our products and a finalized engineering design. So it may not be, cosmetically perfect, it may not work perfectly, but it's roughly it has all the pieces of the final design. They're roughly where they need to be. They work roughly how they need to, and the bulk of the engineering work is finished. This is usually the hardest phase, and in fact, many of the programs I've worked on, had to extend EVT again and again. And in fact, there is one specific program that my ex-colleagues of mine and I laugh about often, where we had 5 EVT builds. So rather than doing one EVT and getting to a good place, we had to do it again and again and again. By the end of EVT, we move on to DVT, which is design validation test. By the end of DVT, we need to have one final configuration. All our manufacturing station must be passing all their tests. So the manufacturing is roughly figured out, and the devices coming out of DVT are almost cosmetically perfect. Oftentimes, there's still 1 or 2 issues. I've never been on a single program that didn't have at least one major problem at DVT, but hopefully most of them might be ironed out, and we're just racing to get the last few kinks worked out. And then last but not least, we have another build cycle, so 6 to 8 weeks before we go back to the factory and redo another build for our production validation tests. And that's the last test build before we start to make the product at scale. And so that PVT builds, in terms of the device itself, it should be all pretty much exactly as good as full on ramp. And in fact, those devices oftentimes end up on shelves. They get sold. They should be cosmetically perfect and they should be ready to sell. But the thing we really want to test is make sure that we can manufacture them at the right yield and speed. Because of course, folks, outside of the industry sometimes think that once you're done with the engineering, the product's ready to sell. But the reality is we not only need to build it, we need to build it fast enough and at a good enough yield that you can actually put enough of them out there in the world. So if all goes well, we've gone through EVT, DVT, PVT, we've got a device that gets progressively more finalized and more perfect. We get to good yields, good cosmetics, and we can build it fast enough. And so we move into ramp. And ramp is when you do full-scale manufacturing and you start accumulating inventory for launch. It's counterintuitive, but in order to have a successful launch and have products at every store, etc., you need to actually manufacture for quite a while. Let's say your manufacturing line can build 50,000 widgets a day, and you need to get 500,000 of them for launch. You'll actually need to have 10 days of full-scale manufacturing before you can even start shipping them to stores and get ready for your launch. So although we're done with most of the engineering work, we need to plan for some time for the manufacturing to actually take place. So typically we say, even an aggressive schedule will have 4 weeks of ramp before you actually get anywhere close to a launch. So altogether, this is a 1-year process to get a device shipped. I will note that many of you likely work on much longer development cycles, much longer NPI cycles. 1-year cycles are typical of what we did at Pebble, for example. It's a consumer electronics device. We were a small company, so we couldn't really design two products in parallel. But of course, if you're working at a large company with major amounts of resources, you'll likely be pipelining your product development so that your NPI timeline might be 2 years, and every year a product ships because you have two teams working in parallel. In order to actually hit that 1 year mark, though, a lot of things have to go right. As you noted, every single milestone is just a 6 to 8 weeks timeline, which means you really, you have very little room for error. And I think, it's extremely impressive how many companies and how many teams year on year ship products on a 1 year timeline. We're going to take a little pause here and take a second for a poll. I'll turn it over to Max.
Okay. So how long did the MPA take on your last product? And I must agree with Francois that 1 year seems terribly short to me. And I didn't notice any mention, Francois, of vacation in there. So,
well, I think one of the tough part about working in this industry is I'm pretty sure that every Christmas holiday I was on call because we had just launched a product and we had to make sure that everything was working all right. So,
yeah.
Vacation was always a roller coaster on that tight schedule.
Always exciting though. So we're going to give a few seconds for everyone to complete the poll. But it takes me back to some of the projects I worked on, and there's nothing. I mean, every milestone is exciting. Maybe it was just that I was young and excitable, but I really did enjoy working on new products. So hopefully we're going to see the results in a moment. Wow. Less than, so 28% of people said less than or equal to 12 months. I mean, that's a third of people are working on new product introductions. I would have, when you started off, Francois, I would have said, not many people were doing that, but 33%, sorry, 28%, another third, less than 18 months. And only 3% now, more than 2 years. Wow. Things have changed since I was a young lad.
Right.
I'll tell you that for nothing. Okay, back to you, Francois.
Yeah, and these numbers really match my experience, which is that, if you can afford it, some companies have 18 to 2 year cycles, which is still very, very fast. But if you're in a very competitive industry, you're trying to move really fast, 12 months or sometimes less, which is very, very challenging, is what we see more and more. And of course, I just talked about a very manufacturing-driven schedule. Manufacturing, of course, is the long pole, and therefore it's what we build our schedule around. But there are many, many other activities that have to take place, and there's a lot of work that has to be coordinated around every discipline that has to work together to get a product launched successfully. Of course, I like to talk a lot about firmware because this is what I do, and so the firmware team will start planning around those manufacturing milestones, and they'll have a few milestones of their own. First, during the proto phase, you need to do bring up. So you need to get every single sensor, your flash chip, your MCU kind of brought up and working and write some firmware and drivers so that you can start instrumenting and you can start animating your device. By the time EVT is around the corner, you need your hardware test firmware to be complete. So the firmware that you need to run your manufacturing line for your first big EVT build needs to be, it will change a little bit more, but it needs to be working. Every subsystem needs to be testable, and you need to be able to exercise some of them on the line. By the time DVT comes around, the firmware team will be cramming to get the manufacturing firmware complete, because after DVT, it's manufacturing pencils down, where we don't change any more of the test fixtures. So the manufacturing firmware has to be final. And that's our first big kind of complete firmware deliverable as a firmware team. As PVT comes around, we need the launch firmware complete, because remember, the PVT units are going to end up on shelves. So they need a firmware that, that they need a firmware that's good enough for unboxing when the users get the device. And then at launch, we like to have a day zero firmware complete. And I will talk about day zero firmware, but oftentimes we'll do one last update that users will OTA their device to when they unbox right before launch so that we can get a few more features out the door. But firmware is not everything. We have manufacturing milestones that we have to hit, marketing milestones that we have to hit, and a marketing team with lots of work to get that launch going. We've got factory automation milestones, a factory automation team that works on the fixtures and the scripts that automate everything in the factory. They have a number of milestones and dependencies with other teams. We've got a cloud team that's building, all of the cloud software that interacts with the IoT device, and they have a number of milestones, and all those milestone interacts. And as you can see, as we add layer after layer after layer, we end up with a very complex set of dependencies and a lot of milestones across a lot of teams. And so that, it turns out, is one of the hardest part of getting, one of the most complex part of getting one of these IoT products out the door, is managing all these dependencies, making sure that you don't end up with teams blocking each other or with kind of a mess of dependencies that no one completely understands that ends up threatening your overall timeline. Because two people, it's like a deadlock. One person's waiting for the other to do something, the other's waiting for the first person to do something, and then nobody does anything. So as a firmware engineer myself, I think a lot about how do I make sure that I remove as many dependencies as possible so that I can get my work done on time and make the launch successful. And on the firmware side, there are 4 techniques that I like to use and that I'll be sharing with you today. Number 1, test-driven development. So building, using test environments to develop our firmware. Number 2 is day zero updates. We talked about that a bit already. Number 3 is using a hardware abstraction layer. And number 4 is splitting our manufacturing and our application firmware. So I'll go over each of these and go into a little bit more details. Number 1, test-driven development. So test-driven development is, I think, very popular and commonly used these days development methodology, where instead of building our firmware, or at least early in the program, on a development board at our desk, we can build it in a pure software environment. So we use a software test harness rather than the real hardware. You can either use a unit testing framework like CPP test to run individual modules. So you're just executing individual modules just cross-compiled on your PC. Or you can use a simulator like Kimu or Renode. I'm a big fan of Renode, and I wrote a long article about it a couple of years ago. These, will not fully simulate every peripheral, but they'll do enough that you can build, 80% of your firmware oftentimes in a purely simulated environment. This means that you can start early on your firmware development. You don't need the hardware to be ready. You can iterate much faster, right? Your compile and test cycles are very fast. And you also, as a side effect, get a robust set of tests that are available to then test your firmware on an ongoing basis as you continue developing it. So it creates a test artifact that is really useful in terms of quality. Next up is the day zero updates. The day zero update is about having a software update applied right at unboxing. So when your users open the device, the first thing they do is update the firmware. This is not the perfect user experience, because of course we want the user to get to the fun part of using your device, or the useful part of using your device, as fast as possible. But it has a lot of advantages from a process perspective, and so I think it's worth doing. The main advantage of the day zero update is that all of this time you spend doing your PVT build and ramping, that's 2, 3, sometimes 4 months of development, you can actually use to finish and polish your firmware. It's a lot of development time that you can extend your schedule by. Here's a little diagram to show kind of what that looks like. If we don't do a day zero update, then we have to complete every single feature of our firmware by PVT, because that's where our launch firmware needs to be complete. But if we allow a day zero update, we get all of this time between PVT, ramp, and launch to continue adding features to our firmware and improving it which allows a few more weeks or months of development time, and that can make the difference between getting all the bugs sorted, all the features launched, and not, especially on a very tight schedule like a 1-year program. I mentioned the hardware abstraction layer. I think today every project should be built on top of a good hardware abstraction layer. A hardware abstraction layer is basically a cross-platform operating system, in effect, or a set of libraries, cross-platform libraries, that can easily be ported to new hardware. So for example, operating systems such as Zephyr come with a really strong hardware abstraction layer, so you can change the MCU or you can change a sensor without having to rewrite all of your code. And that's really, really useful because you might have changes mid-program, or you might have iterative products that you launch 1 year after another. And if you can reuse a lot of codes with a strong hardware abstraction layer, you'll save a ton of time. So decoupling the firmware from the hardware here in a very tangible way has benefits beyond just the schedule. It creates optionality in your supply chain, and it helps you with code reuse, which is a best practice nowadays. Last but not least, I talked about splitting our manufacturing and our application firmware. Here again, this is about decoupling things. If devices are manufactured with a final application firmware on the manufacturing line, then your deadline for firmware complete is even earlier because the manufacturing firmware has to be complete by DVT. So instead, we build a purpose-built firmware just for the manufacturing process that we change very little and that we lock at DVT. And then at the end of the line, of the assembly line, when every test has been run, we load the final application firmware that goes in the box and the user experiences. This saves code space because you don't have to have the manufacturing functions in your firmware. It lets you iterate on your firmware without impacting manufacturing, right? If you introduce a bug in one of your test builds during the program, you don't risk failing a build because you change something that impacts manufacturing. But I will call out one thing, which is sometimes you have some software dependencies between your manufacturing firmware and your application firmware. And so if you're not careful, this can introduce some headaches. I will tell you a story. I worked on a device that needed very careful calibration of a sensor. And that sensor, of course, was configured with a set of register writes and reads, initialized with a set of register writes and reads. And sometimes in the program, we changed one of those configurations. And we said, oh, we're going to kind of change one of the gains on a sensor. We did not update it in the manufacturing firmware, and we updated it in the application firmware. So all of a sudden, all of our calibration was wrong. And that actually ended up losing us 4 weeks in the program. So it had a major impact. Okay, so let's talk about de-risking launch. We've talked about shipping on time, but how do we make sure that the launch goes well beyond that, right? Because of course, shipping on time could just mean we just arbitrarily chose a date and shipped it. It may not be working. Okay, so congratulations, you've launched. It's happening. We're very happy, very excited. For 48 hours, it's the best day of the year, and then reality sets in. The work continues, right? We've shipped, and now we start seeing bug reports, returns from customers, RMAs. We hear about a potential security issue that we get very worried about, or we realize that there's a feature that we really should have shipped, and we want to, send in a follow-on update. And all of those things, come very quickly, and they create a ton of work and sometimes even some anxiety from the product team. And before you say, oh, my firmware works pretty well, I think I'm going to be okay. Everyone I talk to, I like to impress upon them, and this will happen to you. Maybe not every program, maybe not even at every company you work at, but a launch that has a major issue is just part of the work, part of the job. And so I use a couple different data points to illustrate that. First, Jack Genzel, who I think many of you likely have heard about, he writes a really solid newsletter about firmware development. He says that for every 1,000 lines of code, on average, there are between 10 and 100 defects, right? So actually, if we have 500,000 lines of code because we have a Bluetooth stack, we have an RTOS, and we have a bunch of libraries for vendors, plus all of our own codes. That's, you know, hundreds of thousands of lines of code, and therefore it's you know, hundreds of thousands of defects, right? A lot of defects. So so that's just kind of the rule of thumb. Number two is not all of these will be major problems that require a patch, but some will. At those numbers, you know, it's kind of the law of large numbers. And also, no matter how well you test, at some point, some user will do something you didn't anticipate, or just by the law of large number, the device will get so much runtime, so much more runtime than you can possibly have in the lab, that you'll hit some weird edge conditions. Even NASA, I think one of the best embedded software organizations in the world, needs to update their firmware to fix bugs. In fact, I have a quote from JPL from 2013 when they mentioned that they shipped 3 upgrades to the Curiosity rover's firmware in the first 16 months of its time on Mars. And one of those upgrades had introduced an unintended crash, which they had to revert and then do another upgrade to fix. So this, you know, this happens to NASA, this will happen to you. So how can we de-risk the launch and make sure that when these issues do pop up, we catch them quickly and we resolve the problems? At Memfault, we like to call the practice of de-risking a launch device reliability engineering. And we see it articulated around 3 main axes: having a good OTA system, having a performance monitoring system so you can know how things are going with your fleet, and having remote debugging capability so that when the device encounters a problem, you can dig into the logs, you can dig into the data and resolve it without having to send out a technician or get an RMA processed. So first, we talk about OTA. I think it's not controversial to say in 2023 that every device, every IoT device should have an OTA mechanism, because OTA is your last line of defense against any kind of problem. If you detect an issue and it must be fixed, OTA is the way you'll resolve it. QA will hopefully alleviate most problems, but OTA has to be your last line of defense. OTA needs to be tested much more extensively than the rest of your system. If OTA is broken, you have no backup. You can't resolve further issues. You can't OTA your way out of an OTA bug. So, you know, I always like to have very robust codes that is used across all programs and is tested extensively all the time. At Pebble, for example, our OTA system was every night, we did 100 firmware updates across a number of watches and different, you know, phone versions and different operating system versions to check that, you know, a developer hadn't checked in a change that impacted OTA negatively. And your OTA system needs to have a few key features, I think, to work properly. It needs to have cohorts, stage rollouts, and the ability to define what we call must pass through releases. I have a couple examples there. So first, cohorts. So this one is obvious. You're not going to update all your fleet all the time. You might have some internal devices, employee devices that are going to be on a different release channel, or you might have beta users that you want to send a different release to, or even different versions of your hardware might require different firmware, right? So you need a way to group your devices and update each group separately. At Memfault, we built a simple cohort system. I have a screenshot on the right, but I also have worked at many companies that built a cohort system internally themselves. You need cohorts so that you can do more experimentation and like A/B tests, and also so that you can do releases on small groups of devices to maybe make sure to resolve an issue that maybe only they are encountering, for example, in a specific country. Number two is stage rollouts as part of your OTA system to make it, you know, work properly, or to, you know, to give you all the tools you need. Stage rollout is the ability to do your OTA updates incrementally across your fleet, starting with 5% of your fleet, then 10% of your fleet, then 30% of your fleet, so that if you if God forbid you had an issue in your new firmware that you're pushing, at least you limit the blast radius, right? If it's only 5% of your fleet and you identify the problem with good, metrics and telemetry, then you can pause the rollouts and resolve the problem before every single device out there is impacted. And again, this is something that unfortunately I have a lot of experience with. I once shipped a firmware update that actually basically uncovered a uninitialized memory error, right? Where we used a variable on the stack that hadn't been initialized. And because we had reshuffled the layout of the stack memory, it now had a different uninitialized value. And it actually prevented further over-the-air updates. It was a very severe bug. But thankfully, we'd done a stage rollout, so we'd only rolled it out to, I think, 3% of our users. And so we're able to segregate those users in their own group, update everybody else to a version that didn't have the bug, and then work with the group of users to either replace their devices, or in some cases we're able to recover from the problem with kind of the right set of like button pushes and so on. Last but not least, when we talk about OTA, I like to talk about must pass through releases. This is something that when folks build an OTA system from scratch, they don't always think about at the beginning, but eventually you need for every project. At some point, you're going to ship a release that is not necessarily fully kind of forward compatible. Like you'll have a gate that devices have to go through to get further releases. So for example, you might be shipping your 3.8 firmware, and a user who's updating from 1.2 to 3.8 might need to go through 2.0, 3.0, and then 3.8. Maybe every major release is a gate that you have to go through. So your OTA system needs to enforce that. And so this is, in the Memfault UI, we implement this with a simple checkbox, and of course a lot of complex logic on the back end. And I'll give you a very concrete example of when this happens. When you ship a firmware update, sometimes you add a feature that hopefully will reactivate some of your users who have stopped using the device. And if those users put the device in a drawer a year ago, and there are multiple firmware versions behind, you're going to need a path for them to be updated to the latest. And it may not always be possible to just jump to the latest. So this is something that every product I've worked on has needed this functionality. So that was OTA. We'll talk about performance metrics. So OTA is our last line of defense, but how do we know whether we need to do an OTA and how well the devices are working? Well, of course, we might just ask our support team, how many texts are you getting? How many people are how many people are complaining, and then maybe we'll just use that. But it's even better if we have metrics and automated data collection. So and to answer the how are my devices doing question. So we might want to know about connectivity, battery life. We might want to know about how responsive the system is. And we need a metric solution that has very low device impact, right? Doesn't consume too much memory, that is privacy respecting because your users will often care about that. That is easy to extend for your engineers as they want to add new metrics. So here again, I'll show you a couple different types of metrics you might want to collect. The first one is individual device metrics. So you might want to collect data points from your devices at a regular interval. So you can then pull up the data from one device and see what it's done over a period of time. So a typical example I give is we track the battery level and the CPU usage and the Bluetooth radio usage and the usage of every sensor, so we can correlate battery drop with specific activation of a sensor, right? And so when a customer calls you to complain, you'll pull up this individual device's timeline and look at all the data you've collected for it. At Memfault, we call this the device timeline, and you have a screenshot of what that looks like on the right. So here again, there are many ways to implement this kind of system. But you'll also want to know on aggregate, how are things going, right? You've collected all these metrics and you can look at individual devices, but what about the overall fleet? What's the average? What's the min? What's the max? And so you'll want some dashboards that aggregate that data. This can be quite complicated to build because sometimes if you have lots of devices, there's lots of data, and therefore there's a good bit of math to do in order to crunch all those numbers. And so, here again, I have some screenshots of how we do that at Memfault. But in short, you'll want a way to look at least your average, your median, your P95, what's your 95th percentile behavior, 99th percentile behavior, and your minimum and your maximum, for example. I think those are common aggregations. If you can see that all in a dashboard, that's super powerful. Even better if, like we do at Memfault, you can compare that from version to version or from cohort of device to cohort of device, so that you can understand, did my battery life regress between firmware 1.3 and firmware 1.4? Once you have these dashboards, the next thing you'll ask is, can I get an alert if something changed with the dashboard instead of having to log in every day and look at the dashboards myself? And of course, that's an obvious thing to do. And so, we built an alert system here also. There are many others, even some open source ones. The idea is we might define some thresholds, right? For example, if our battery life, again, my favorite example, if our battery life goes down to less than 4 days, right? Can I get an email to my engineering team that says, hey, average battery life in the field has gone down to 4 days recently? And then you can go and investigate. You might get Slack messages or even integrate with an incident management platform like PagerDuty. We have a few customers who do that. And I talk about battery life a lot, by the way, because at Pebble, we were so focused on battery life that I'm still a little bit, I have the scars to show it. It's the example that was the most salient for me early in my career. Okay, we talked about metrics, we talked about OTA. The last thing I'll talk about is remote debugging. So remote debugging for me is the ultimate developer tool, right? We've all been there. A bunch of customers call you and say, hey, I can't get my device to do X, or something is going wrong. The device isn't responding, it's not turning on, or whatever else might be going wrong. And those reports have gone to your support team and they've gone escalated to engineering, and you've even processed a couple returns to look at the devices in person. It's a very long process and sometimes very labor intensive. I myself used to crack devices open in the lab, so that we can connect some wires on the JTAG pins and try to understand what our customers might have complained about. So with a remote debugging system, the idea is we can collect some of these reports automatically directly from the device by hooking into fault handlers and hooking into facilities offered by the RTOS or different libraries to understand when an error happens. Then we push this all to the clouds where we deduplicate it and analyze it automatically, and then raise alerts to engineers if new issues are found. So instead of spending weeks kind of meandering through support, a problem will get automatically reported, and in under 2 minutes, an engineer might have gotten a ping about it. The key tool around remote debugging is what I call core dumps. So it's automatic data collection of memory, register, and log data that we lump into a single payload and upload to the clouds. At Memfault, we have a core dump system and decoder. You can see an example on the right that will show you the backtrace, the memory, the register values at the time an issue was encountered, and do a lot of automated analysis. And the idea is that with this information, an engineer should be able to resolve a problem without having to get a device back in the lab or sending out a technician. It has saved my butt many times having a core dump systems on some of the products I've worked on in the past. With that, I'll turn it over back to Max for our last poll. I'll be curious to hear which of these systems you have implemented.
Well, thank you, Francois. I would like to remind everyone, please do click on the poll so we can see what you think about all this. But also, we are going to have a question and answer session at the end of Francois' talk. So if you can enter, if you have questions, we have the question interface as part of the webinar interface for you to pose those questions. And then I will be presenting the questions to Francois at the end in our Q&A session. One of the things that really struck me, Francois, was when you were talking about the DVT and you said pencils down. at the DVT point. When I started designing ASICs, we had no EDA tools. All we had was a pencil and paper, and we designed at the gate level with pencil and paper. So the pencils down thing just really struck a chord there.
It was literal.
Yeah. And also, I mean, what you're doing here when I started was the stuff of science fiction. The concept of an OTA, over the air updates, was just, we never thought about it. We didn't even have a network. This was before Ethernet became standard. So if a bug occurred in the field, you absolutely did have to send a technician out. Of course, we didn't have mobile devices either. You know, we were designing room-sized computers, but the sort of being able to diagnose over the air was mind-blowing. Would have been mind-blowing to us.
And I'm not that old, Max, but even early in my career, I worked on devices that were, had a single write. You burned the firmware into the device in the factory, and it was never updated. It was not updatable, right? So this is new capability in many cases.
Well, those were the days when an embedded system was one you didn't even know existed until it stopped working.
Right.
Okay, so the results. What infrastructure do you have in place today? Well, 72% of the people have OTA. And to be honest, I'm surprised it's that low these days. I would have thought almost everyone would have been having it. Only 31% have metrics. Only 19% have remote debugging. And there's 19% of the people in the audience at the minute who have tears rolling down their cheek, realizing how far behind the scene they are. Okay, back to you, Francois.
This poll shows me how much work there is left to do, right? 19% of folks who have remote debugging, a tool that has become essential to my workflow in my work. And this is, of course, I'm convinced about this, so much so that I've ended up building a business and building a whole platform to provide these tools to other engineers. So useful they have been for me. So, I just like to end by saying that at Memfault, we've built a single tool that implements all these best practices and gives you the ability to push these OTA updates, collect those metrics, and collect these automated error reports so you can debug without having to get your J-Link connected directly to the device every time you want to find out something. I'm very excited about the things we've built, and I hope you'll check them out. And of course, as always, don't hesitate to reach out to me if there's anything that you want to discuss further. And with that, we might turn it over to questions, Max.
That was very, very interesting. I've been making so many notes, and all the things that you came up with, I thought, wow, that's a good idea. Like the cohorts. I mean, once you've said it, I think, why didn't I think of that?
Right.
And but rather than updating everyone with the whole thing about doing it a phased release, so you don't update everyone with something that doesn't work. Very, very interesting indeed. And again, I'll remind everyone, we have got questions coming in, but this was the best time that we've got for you to pose more questions. So let's see what we've got here. Okay, so does Memfault, this is from one of the users, require us, the user, to use your firmware over-the-air solution? Or can we just use your remote debugging and metrics software if we already have our own OTA implementation?
Absolutely, and this happens all the time. We're not dogmatic about folks using every single one of our tools. I think the majority of our customers actually come with an OTA system already built, and of course they don't want to change that mid-program. That's too risky. And so they choose to maybe only use the remote debugging because that's what they need at that moment. And hopefully down the line they decide, why are we building these custom OTA systems when we can just use the ones that Memfault, who we already work with, has? But it's not required, and it's, I'm not upset if you choose not to.
Okay. Okay, so can you give us an example, somebody's asking, of an alert or flag that you've used or seen to catch issues on portable wearable devices?
Yeah, I can think of a few examples. I think, for me, again, the battery life has always been something that I obsessed over and was very stressed out by. And so one thing that we did pretty early on the Pebble watch is every hour the device would send the amount of battery that had consumed in that hour. So we're not sending the battery level, we're sending the delta every hour. And so then imagine you have a thousand devices, each sending the delta. You can average that across all the devices and extrapolate to figure out if I drop 4% on average every hour, then my average battery life is this many days, right? And so within an hour or 2 hours of shipping a new firmware, we could get an alert that says, hey, battery life in the field has regressed from 5 days to 4.7 days, and we would take action right away. And so these kinds of alerts were essential to our work. We use them every day.
It's not a question here, but somebody has said, another Sun Workstation success story. Congratulations. Very interesting tool set. That's nice. I never worked for Sun, but I did know quite a few people who did work there. All right, an interesting one here. How do you determine who gets a staged release? Is it random, or do you communicate with specific users that they're part of the stage release? I wouldn't.
Yeah, we don't communicate with them. So by default, it's randomized. So if you wanted to send a release to a named number of users, then instead of doing a stage release, you would just create a new cohort, right? You'd say, cohort A, I'll put the 100 users that I want to get this release, and I can message to them that they're in a special group. But if you're just trying to, do a controlled rollout, a little bit at a time, I think random sampling is the way to go, and that's how our system works.
Mm-hmm. In that case, this is from me, would you do a different random sample each time, or would you stick with the same random sample each time?
I think you'd want to have a different random sample each time because that's what we do anyways. But the reason for that is, first of all, it's less bookkeeping you have to do, right? You don't have to keep track of your previous random samples. But more importantly, so that you avoid introducing bias, right? Like your first random sample might have bias in it, or perhaps new users have showed up since you initially created it. And so if you start using it for every single one of your release, you might end up with bias in your sample, whereas resampling every time will avoid this problem.
Okay. Also, it seems a bit unfair to have the same people as the guinea pigs.
Right. Not unless they signed up for it and they're beta users, but
That's
yes,
true.
absolutely.
Okay. Well, this is this is a slam dunk for you. How easy is it to incorporate the Memfault system? Oh, it's very easy.
Well, let's use some hard numbers here, right? Like so Memfault today works on Android, Linux, real-time operating systems, and bare metal devices, and each of them is a slightly different integration. On the easy side of the scale, if you're on, Android, Linux, or on Zephyr, for example, which we support really, really well, it's less than a day of work. You just typically just flip a switch in a configuration file, and you're mostly done. But if you're on a bare metal system or you have a custom RTOS you've built yourself, on average it takes about 2 weeks of engineering work to integrate. So it's real work. It's not just one evening.
Okay. So when you launch a product and are considering an OTA update, do you plan to not have that firmware or software engineer to be available on something new for some period of time to support the OTA? Interesting question.
Yeah, that's a very interesting question. I think I've seen it done both ways, but in my opinion, if you wrote the code, you own it, and you should be around to fix it. Some companies will hand off the firmware to a sustaining team at launch or very quickly after launch of a different set of engineers who didn't write the code or see the code until it was handed off to them. I think you need ownership, right? Like if
Yeah.
you're the person who wrote the code, you're most likely to be the person who can fix it the fastest. And I also think it enforces some level of accountability if you're responsible for your bugs. And so I typically say after you ship your product, first the first month, your firmware engineers who built it are dedicated to sustaining. And then after the first month, if things are looking okay, you can make it a 10% or 20% thing, right? Where they're expected to keep a look, and jump on issues that might pop up, but it's no longer their primary day-to-day responsibility. And that tends to work pretty well.
Makes total sense, because the last thing you want is an unhappy customer.
Exactly.
Happy customers come back, unhappy customers don't. How do we deal with day zero updates when not all devices will be connected?
Right. So this goes into some the user's experience side of things. And I will first start by saying that not every device will use the same techniques. I think some of that is really unique to your business and your device. But in general, when your user unboxes a device, you're going to have some sort of an onboarding flow, right? They have to turn it on, then they have to download the app on their phone or something like that. Then they have to connect it to their Wi-Fi network, and then they have to maybe create an account with an email address and a password, right? And so in this onboarding flow that is required, right, they have to go through it to start using the device. You add a firmware update step. That's kind of how I usually see it done, and I recommend that it's done so that the firmware update is a required step to start using the device fully as you onboard. Of course, that requires that your firmware updates not be too long, right? If your device takes 2 hours to update, it's going to be very frustrating to your user.
Yeah.
And so I think there's some careful design considerations here. In an ideal world, it takes 3 or 4 minutes to update the device, maybe 5, and you have a gauge on your app that shows it progressing for the users so that they can be onboarded in less than 15-20 minutes.
Yeah, there's a company called PureVPN that I use, and when they're doing an update, they have a little cartoon figure who's plants a seed. He's in a spacesuit on a small asteroid. He plants a seed, then he puts some water on it, and then it keeps you busy while you're so busy watching the animation you don't realize what's going on with the rest. And the other thing is, I mean, these days it's hard to imagine a device that's not connected.
100%.
It's like, why would you buy it if it's not connected? Okay, so let's see. Keeping a careful eye on the time here. How much bandwidth or data volume do you typically need for a single device to upload all of its metrics and diagnostics?
It depends a little bit on the device itself again. So for example, an Android-based device, which is a much more complex system, might upload a lot more data. But talking about a classic, typical IoT device using, a real-time, like a FreeRTOS type system, you're looking at, tens of kilobytes per day on average. I think fairly low amounts of bandwidth. And it's tunable. So if you're very limited, so we have a customer, for example, who makes hurricane measurement buoys. So they get thrown into the ocean, into the eye of hurricanes to measure the speed of the winds and things like that. Very cool company called So Far Ocean. And they're connected via satellite connectivity, right? Iridium satellites, because you don't have Wi-Fi in the middle of the ocean. And so their bandwidth is very, very limited. So we worked with them to tune the diagnostics information we collect to be, hundreds of byte payloads, right? Which is sent a couple times a day. And that still works quite well.
Especially with the new satellite networks going up.
Yeah, it's not going to be a problem in the future. I mean, if with those lower 4-bit satellite networks, which nowadays can deliver, tens of megabit per second or hundreds of megabit per second bandwidth. Perhaps we'll have worldwide, huge high bandwidth for all IoT devices, and I think that will change a lot of things.
Oh yeah, one of the guys I work with on various projects, he goes up to Alaska, sailing a boat up in Alaska for about 2 months of the summer. And it used to be the only access I had was satellite SMS messages, so limited to about 100 characters. And mostly it was when will you be back in Wi-Fi range? And this year he's got the Elon Musk network, and he's got total connectivity. We Zoom, we do anything we want. It's game changing. Another one for you. Does Memfault provide any device level security detection features, tampering or network hacking attempts?
So some of our customers use our metrics and our logging to detect security incidents. So for example, you might collect some network statistics that tell you that can be indicative of a hacking attempt, or you might have a temper sensor that you want to collect as a metric in the Memfault system. So overall, there are quite a few ways to use a flexible metric and error reporting system to collect security information. At the same time, today Memfault doesn't have, a security-focused offering. Like, we don't have a Memfault security product that automatically collects very precise security information. So there's usually a little bit of a collaboration needed there. But it's something that I hope we can do more in the future, do more of in the future.
Okay, well, I think we've got time for one more question. And also one more comment from me, because, like my mother, it's the trick is to get us to stop talking. But you were talking about Jack Gansel, who I know very well, and him saying that, as a rule of thumb, there's 10 to 100 faults for every 1,000 lines of code. A lot of people these days are using Copilot. In fact, I've heard that 60% of the code that's generated now is generated via Copilot. The problem is that 40% of that code has bugs, because Copilot was trained on open source, and there's lots of little security bugs and things. And so there's a company out there that I ran into recently called Meta B-O-B. And they have a generative AI solution that looks at your code and spots the security issues or memory leakage issues, and gives you solutions, and it just goes through the code highlighting them. So it's an AI that helps you fix the bugs that the other AI puts in.
Wow.
We truly do live in interesting times. All right, last question. This is a good one, how do you ensure the integrity of the updates that you send out?
Very complex topic. I wrote a long blog post about it. I think the gold standard, in my opinion, for updates integrity guarantees is, ECC signatures. So having basically a elliptic curve, using elliptic curve cryptography, which can be deployed on very small devices, requires few resources, to sign the firmware using a private key that identifies, the manufacturer as the person who built that firmware. And so we help our customers deploy ECC and sign their firmware. Some more sophisticated players might actually sign their firmware per user, so create an update that's signed for a specific user rather than signing every update with our manufacturer key. It's a complex topic. We could have a whole talk about it, but in general, I say, at the very least, make sure you have some sort of firmware signing system in place. I wrote a whole blog post with open source code on how to do it. I recommend people check that out. And look into ECC, electric curve cryptography, which is a lot easier to deploy on an IoT device than standard AES style systems, which take a lot of code space and memory.
Actually, that gives me a really nice opening to say, if you want to know more about that, contact François directly. François kindly said, as you can see on the screen, he's offered his email. So if you've got any questions that pop up after this webinar, you can email him with them. And also anyone who asked questions, this is still coming in, that we didn't have time to answer. Francois kindly says that he will reach out to you and send you an answer via email. He'll use the email that you used to sign into the webinar. That was incredibly interesting, Francois. Thank you so much. I'm afraid to say that this does bring today's webinar to a close. So thanks to everyone for joining us, with a special thanks once again to Memfault for their sponsorship, and especially to Francois for his insightful presentation. Once again, this is Clive Maxfield. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And until then, from all of us here at IoT Central, we hope you have a wonderful rest of your day.
Thank you, Max, and thank you everyone for the wonderful questions.
Thank you, Francois.